The first announcement I want to announce is thank you, Corinne, for letting me know that my YouTube video for Monday and Tuesday class is exactly the same. Thank you, Corinne, for letting me know. I actually deleted that Tuesday class, and I will be uploading the YouTube today after class to um let me share my screen here so you guys know what I'm talking about here. Um, right here. So if you guys look at my Monday and Tuesday, actually I uploaded the wrong video. So there's a reason why that the Monday and Tuesday, this Monday and this Tuesday class video is exactly the same. So we are going over 3.3 and 5.1. Thank you, Corey, for letting me know. So I will re-upload this again. So you will be after class, so you will see a new 5.1 and 5.2 video. So those who watch Tuesday class video, sorry about that. So I will re-upload this again so that you won't that's a mistake. So, as I mentioned, I'm a human, I make a mistake, and thank you, Corinne, for letting me know. And then I will then I'll upload today's class. So again, if you see any mistakes or any questions, anything weird coming out in the video, please let me know because sometimes I click the wrong button here. So I will re-upload this again so you guys can watch this. So that's the first announcement here. Second announcement is I am currently typing out the Stack Crunch I'm not shortcut, should be Stack Crunch uh how do you find this, so I am currently doing it right now. So you will see this in D2L, and I'll send it to you today after class once I finish typing this all up. So you will find out what is going on. And this is for just for this midterm. So from chapter 1 to chapter 6. So I will try my best to see if I miss anything. So I'm still typing this out so that you guys can actually I'm going to let you use this in your test so you guys can use this in your test. So I will go through this together with you. It's kind of the same thing from the notes, so you guys do not need to worry about that. Okay. Next is the midterm. So the midterm is gonna be on the coming Wednesday, July 3rd, 10 to 12, 2-hour test here. CBT 160, we're gonna go chapter 1, 2, 3, 5, and 6, including 6.4. You're allowed to use one front page of notes. You're allowed to use any calculators, no cell phone calculators. If you do not have a calculator, you can borrow it from me. And this test is going to be in a computer lab. If you have a laptop, you can bring your laptop to class on test days. You can use a laptop. Otherwise, if you don't have a laptop, make sure you use a computer there. I do suggest you guys to come early on the Wednesday, maybe 10, 15 minutes early to find where is CBT 160. And especially those who are using the computer at the college, it might take some time for you to upload it, to run it. So make sure you know your star ID and your password because that is the one that is required you to use it. So if you doesn't know or forget your star ID or password, you have to go to the technology, I don't know, the IT, the internet, yeah, IT people to get help over there. So please make sure you know how to get into your computer, the school computer here using your star ID and your password. The review, you can find a review in D2L or in this email. So the review is right here. So this is a review for the midterm and the key is given right here. So I would suggest do not look at the key first. Try to do the review piece and then the key in there. So make sure you guys know how to, this is a review. So some of you ask me, do you want to turn it in? You do not need to turn it in. This is something that you practice. Pretest, we will be having, so pretest is right over here. So there is a midterm pretest. I will recommend you to print out this pretest, click on it and print it out. If you want to go over the pretest this weekend and, go for it. If you want to print more than one copy, and do more practice, go for it. I will suggest which one you want to concentrate on. Please concentrate on the pre-test, okay? The pre-test is very similar to your test in this case, okay? And then please go, we will go over this pre-test on the class on Monday, July 1st. So I would recommend please print this out first. And I don't have, as I mentioned, because our midterm is 2 hours long and our class only meet 1.5 hours. So we don't meet on Tuesday, July 2nd. So that is your study day. So make sure you take the July 2nd Tuesday class to study your material or do your homework. I will tell you that that is quite a bit of homework due on this coming Wednesday. 6 homework to be precise, 3.3, 5.15, 261, 6264. A lot of homework due on this coming Wednesday. So I would recommend take that Tuesday, which is no class, no school, study day, to work on your homework, study for your tests, and so on. And then when you come on Wednesday, we do have a 2 hours midterms in this case. Same thing happens to your finals. The day before the finals is no school, it's a study day for you. And then after that, you will have a study day. You have a final, sorry. Study days and then finals. So make sure you guys know this. This is super important. Now, for those students who do not got this email, cannot find this email, you can also go under materials and content. This is where you will find the review for the tests here. So if you click the review of the tests on here, this is the review for the test, the same documents that I just posted. And the pretest, which is the midterm pretest in this case. And then once we finish the midterm pretest on Monday, I will post the key in there. So you can do the midterm, you can see what is the midterm pretest key looks like. And I just take a look at this so you guys know what it looks like for the midterm pretest. This is the midterm pretest. As I mentioned, it's very similar to your test. So there will be around 5 open-ended questions here. And yes, we'll go over this in class on Monday. So that means that you will have 5 open-ended questions in your midterm. And then there will be around 12 or 13 multiple choice questions. And then some of you will ask me, where is the multiple choice question? I will say your homework. Remember, you do your online homework. Mostly some of them have an MCQ multiple choice question. Those will be the one that you will see in there. So the pretest that you get here is very similar to your midterms here, the open-ended, which give you the most points because each of these questions will be either 5 to 10, even like this question number 3 is like 20 points. Okay, the whole midterm is 70 points total, and question 3 already took 20 points of it. Okay, and the multiple choice questions, you do not need to show me any work. It's MCQ, so you just need to tell me, is that A, B, C, D, E? You have to you have to circle your answer here. Please make sure you circle 1 correct answer here. And some of you were asking me also, where can I find the multiple choice? Go to the review. So remember the review midterm that I sent to you here. So mostly this review, the first chapter, remember, where we do all the statistics, the discrete, those nominal, those are the one that you will see as the multiple choice questions. So I will recommend that if you want to do figure out which one is a multiple choice question, I will suggest you to do the chapter 1 material and chapter 2. Chapter 1 and chapter 2 mostly are coming up in the multiple choice question. So try to do this kind of questions. So I would highly recommend you to try it yourself here. And then this is again the weekend practice here or during that Tuesday free day. Okay. Anyone have any questions so far with announcement going on? Okay. And again, I'm still working on this StatCrunch here, so you will get to use of it. And I will provide you a copy of this in your test, so you do not need to print it out, write it out, or something else. So you actually read what it is in there. Okay, so that will be the stuff that I'll go over. Okay. Any questions? All right.
Question.
So, yep. Yes.
Will there be other StatCrunch shortcuts?
Oh yeah. I haven't finished typing this out.
Okay, because there's
Yeah.
a couple
Mhm.
graphs and stats that I couldn't find instructions easily on when
Yep.
doing homework.
Yep. So I will type mostly the other graph that I put in the next one will be the box plot. Yep. So the graph that you guys supposed to do is histogram and box plot. Mm-hmm. Yeah, I'm still typing this out. So you will get a full stack crunch. And then on Monday class, I will go over this with you guys. Yep. I'm just starting typing it. So yeah, so don't worry about that. It's not finished yet. Okay. All right. Any questions? So today's work, we go over to 6.2 and 6.4. So 6.2 is where we do the normal distribution. So what is the difference between 6.1 and 6.2? Now, 6.1, we're going over what we call as a standard normal distribution, where the population mean is always 0 and the population standard deviation is always 1. So this is the standard normal distribution. And if you remember the picture, that the area that we shaded here is called the probability. And then the on the x-axis, we call this value your z-scores. Okay, so this is for the standard normal distribution, where the mean is population mean 0 and the population saturation is 1. Now, when you look at 6.2, we will call this as normal distribution. No longer have the word standard normal. This is just a normal distribution. So what is a normal distribution? A normal distribution is a normal bell-shaped curve. Pardon my normal curve here. The only difference here is that your mean is gonna be your population mean and your population saturation is gonna be a different number instead of 0 and 1. Remember, in the standard normal distribution, the mean is always 0, the standard deviation is always 1. But in this case, the population mean and population is any number you can have. Okay, it can be 5, 10, any number you want. We still have the shading area we have here, the density curve we call it. This is still under your probability. Okay, so your area is still the same thing as your probability. And then last time in the value down here, we call this as your z-score. In this case, we will call this value random variable x. Okay, so now this variable down here is no longer a z-score. It is a random variable x. What is random variable again? This is where we talk about in 5.1. So random variable is a numerical value of an outcome, of each outcome of a procedure. So this is the random variable that we learned in 5.1. So that 5.1 random variable x that we learned here is exactly the same random variable x that we will use in the normal distribution. Okay, that means that this number is no longer 0, not longer z-score. Remember last time we do z-score, the middle number have been 0 and then 1, 2, 3, 4, and then negative 1, 2, 3, 4 on the left side. So that is called a z-score. But this time, this random variable x can be any number we can have. Okay, depends on what the outcome of the procedure. So let's say if you talk about test score, then the random variable x is from 0 to 100. If you have if your test score points are from 0 to 100%, so that would be 0 to 100. So if you talk about height, then this will be like the 0 to maybe, I don't know, 8 feet tall. That's the height. So so the random variable x in this case can be any numbers that is that a variable can take place. Okay, so and then so make sure you guys know the difference between this. Okay, so if you look carefully on here, we have the probability and we have the x score now. So we don't call this as your z score, we call this as your x score here. But in your stack crunch, we call that as your reference value. Okay, So this is called as your reference value. Okay. So when you guys do this, make sure that in StatCrunch, we will, no matter which one you do, you still use stat calculator normal, which is the same as what we do on 6.1. However, your mean and your standard deviation, in this case, I give you a symbol here, mu and sigma, means that this mu and sigma is going to be given in the question. Okay. So make sure you read the question carefully and they will give you the mu and the sigma in this case. Okay. And the same thing, make sure we always do 3 types greater than. We will use greater than or equal to here. And then less than, we use less or equal to. And if you have a between one, make sure you use the between line, which is the same thing as what you did in 6.1. So as I mentioned, if you know how to do 6.1, you should know how to do 6.2. Okay. And as usual, when you type this in your StatCruncher, you got 2 choices. Either you do x is less than or equals to, and then you got the first blank, and then you got the second blank here. You guys just dot in the blank. And again, as I want to point out, the value, the reference value has to be on the first blank, and the probability has to be on the second blank. This is very important. This is exactly the same we just did on 6.1. I can show it to you what the StatCrunch looks like. So go to stats, calculators, binomial. Oh, no, not binomial, sorry, normal. Stats, calculator, normal. Sorry, very normal here, which is a normal curve here. So last time the mean is 0, standard is 1. So this time it can be any number. And then this is, you can change from less than or greater than. And if you want between, you switch it to the between sign here. And this is always a reference value. Last time we put the z-score in here. Now it is a x value. And then this is still a probability on the other side. So make sure you know which one is which. Okay. So there are some hint here. Make sure you know that when you do the probability, it has to have no units and the value has to be between 0 and 1. Okay, no units and the value has to be between 0 and 1. For the x-score, it has units, and then your answer is any numbers. Can be positive, can be number negative, can be 0, can be any number. Okay, so make sure you guys know which one to fill, to put into your StatCruncher. Do not mix it up. The first caution about this is do not get confused between the values, the z-score and x-values and the areas. Because if you get confused between these two, or you put in the wrong place in your StatCrunch, you'll get the wrong answer. So make sure you know which one is which. Next, make sure you know where you shade, right side or left side. If I ask for the top 10%, your shading is on the right side, not top is right. And then if you want to be the bottom 10%, then your shading is on the left side. So make sure your shading is correct, because if you get wrong shading, you end up with a wrong answer here. Then make sure that the areas and the probabilities are always in positive and or 0. It can never be negative. Okay, so your areas or probabilities always have to be from 0 to 1. Okay, so that means that you cannot have any negative values. You cannot have any number bigger than 1. But it can be 0, it can be 1, or any number from 0 to 1. So make sure you know that. And the last thing is make sure you draw the graph. Okay, the graph that we just draw on 6.1, the normal graph. And make sure this normal graph also match with the StatCrunch graph that you draw here. If you match with the shading and everything, then you're probably in the correct form, but otherwise you will probably end up wrong. Okay. So it's very similar to 6.1 in other words. Questions for 6.2? Right. So for question number one, we will look for assuming that adults have an IQ score that are normally distributed. So the word normally distributed is very important to us because that will tell us we are using normal distribution. But this time your mean is 100 and your standard deviation is 15. Okay. So last time the mean is 0, standard deviation is 1, but this time is no longer that. Okay. Now, this entire sentence that you read here is for population. The reason why that this whole entire sentence you read here is for population is because they don't give us a sample. Okay. So how do we know if it's a sample? The whole we're talking about sample, not the population. Is they will give you a sample size in this case. For example, is if you look back at 5.2 that we did here. So we are picking this 10 randomly of 10. So this n, the 10, the random select 10, this is your sample in this case. So once they mention this, how many people they pick randomly, then that is going to be a sample in this case. But if you can read this question number one here, they don't even mention how many people picked here or how many people pick randomly here. So we automatically default this as a sample, as a population. Okay. So majority of the word that you see here on this 6.2 and also 6.4 is all these are for population in this case. Okay. You will see something in chapter 7 that looks like a sample to you, is where they start to pick people randomly in this case. Okay. So that means you know n. So normally right here, they don't have n in this case. Okay. So for this question A, they want you to find the probability that a randomly selected has an IQ score that is less than 115. So as usual class, you will have to draw the pictures and the three things, right? Draw the pictures and then use the StatCrunch and then write down the last sentence in the StatCrunch that we did last time here. So we're going to do the same thing on this case. So in question A here, how do you draw the picture for that case? Your mean is always in the middle. This is how you label it in your in the picture here. Your mean is 100. So you put it right here. And the standard deviation is 15. And you're going to find the probability that this is less than 115. So 115 is somewhere here. This is 115, somewhere here. Okay. And then the word less than means your shading is on the left side. So this is what the picture looks like. And yes, when I graded this in your midterm for your test here, I will need to look for a few things. One, I need to look for your mean and the standard deviation. Second thing, I want to figure out what value is this, 115. And third thing, the shading has to be correct, which is less than. So this will give you a point here. So make sure I'm checking for all this stuff. And then the next thing is we're going to use StatCrunch to do this work. So now you have to enter your mean, which is in this case is 100. And your standard deviation is 15. Less than means is less than or equal to, and then we will use 115 from the question given as 115 here. When you hit compute, you find out that the questions look very, the picture looks very similar, and then this fellow will be your answer in this case. So you're gonna type this whole thing up here. So, so your answer in this case is P x less than or equals to 115. This is equals to 0.8413. Usually they want in 4 decimal place, like what we did last time. So that would be something that I'll be asking you to do. And this 0.8413 is your answer in this case. Anyone have any questions here? Because very similar to question 6.1, the standard normal distribution here. Okay. Same thing happens to question B. You have to find a probability between the probability that a random set of adults is between 90 to 110. So for this question is you will draw 100. and 15, and you will find in between 90. So 90 is on the left side of 100. Make sure you know that. And 110, which is on the right side of 100. So this is, and then your shading is in the middle. So this is in between. So how do you find this in between probability? You have to use the between on the normal calculator. The mean is still 100, the standard deviation is still 15, but you want to find in between 90 to 110. Okay, so this is what you have to type in, and the answer will be right over here. So that's your answer. So 0.4950. So probability of 90 less than or equals to x less than or equals to 110. This is actually 0.4950. Okay. You guys all right here with this one? And this is your answer we're looking for here. Anyone have any questions for me? Question C, we will find the probability that the IQ score is more than 140. Okay, so for this case, we will draw the normal curve. Again, in the test, you do not need to draw me a nice normal curve, just a basic normal curve will work here. Okay, and the mean in this case is still 100. The standard deviation is still 15. So this is the same as the rest, but this time is more than 140. So 140 is somewhere on the right side of 100, way a little bit out right here. And more than means you're shaded on the right. Oh, by the way, I forgot to check. This picture and this picture should match. So how do we do question C here? More than 140. So we're going to go back to the standard for the more than or less than. More than means you have to go greater than or equal to, and then you do 140 here. So again, this picture is very similar to that picture here. So your probability will be 0.0038. So that is your answer for question C. So probability of X greater than or equals to 140 is equals to 0.0038. So again, these are the few things I will look for in the test. One, the picture has to have all this information, the shading, the number, the mean, the standard deviation, and definitely the normal curve. Two, I want you to give me the last sentence in your StatCruncher. And then three, make sure your answer is correct. So that's where the 3 points will be located in this case. Okay. Now, if you notice, the first three questions, A, B, C, is asking you to find the probability. So that's the reason why that your answer be looking for is on this side, on the second box. But for this question is, they don't want you to find the probability. They want you to find the 30th percentile, which is the bottom 30 separated from the top 70. Okay. So this is a little bit different story here, is because in part C, we will be doing the different way, which is I will show to you right now. But however, the mean and the standard deviation is still 115 here. Okay, where if you want to find the 30th percentile, 30th percentile means the bottom 30%. As you know, that bottom is always from the left side. Some you ask me, is that always on the right? No, you always count percentile, always count on the left. And 30% means it's somewhere here. So this is 30 percentile. Okay. And in StatCrunch, they do not like to use percent. You have to change it into decimal. So 30% is 0.30. So you are actually finding this value. That is what the question wants you to do. Okay. So how do we do this in your StatCrunch is, again, mean and standard is 115 in this case. Since our shading is on the left because of the bottom 30%, so you can move it to the bottom, but make less than or equal to. But the 30% that you're going to put in here is going to be under probability, or in this case, your area. So that means that you have to put the 30% on the second box. So we are looking for the value in this case. So that answer in this case is 92.13. Again, I put this in 2 decimal place. Class, I'm not worried about rounding here. If a question doesn't ask you how many decimal places you round, again, in the test, 2 or 3 or even 4 decimal places is what I'll ask you for. So this is the answer for this case. So when you put this in your stack cruncher, you will just need to write down as P X less than or equals to the box. And this is 0.30. So this is what you're going to put it down as your task. And then the box in this case shows it is 92.13. Okay, and that's your answer in this case. So again, the very last sentence, sentence, you put it in here. If you want, you can put 92.13 here, also fine with me. I'm not that picky here. Okay. I kind of know what your answer is. Questions? This is how we do question D here. It's a little bit different from question ABC. Anyone have any questions for me with this example? All right, so question 2 is kind of the same thing. The man's height up normally distributed with the mean. I'm going to use green again for the man here. With the mean of 69 inches and a standard deviation of 2.8 inches. So this is for man. And then the women one, I will change to another color. Violet here. So women's are normally distributed with the mean of 63 and a standard deviation of 2.5. Okay. So then the question is asking for what the monorail in Disneyland is actually having a height of 72 inches. So the question says, we got a door here in the monorail. Monorail is kind of like a train that carry passengers slower. It's going to be the height of the door is 72 inches. So the question question 2A is asking us that what percentage of adult men can go through the door without bending. Now, this time the question here did not give us number like less than or in between or more than. They ask you that it goes through the door without bending. So what does that mean in this case is because the door is 72 inches. So when you want to go through the door without bending means your height should be less than 72 inches. So this means that this should be less than or equals to 72 inches. Okay. So the question now is very they don't give you the number anymore. They ask you for for this case. So make sure you guys know that that the question is asking for that. Okay. So how do we do question A in this case is again we do the monorail, the normal curve here, okay, where the mean, now we're doing man in this case, so that's why I just highlight this all in green. The mean height of man in this case is 69 inches with a standard deviation of 2.8. And you want to figure out what is the percentage of men without, so 72 inches or lower. So this is 72 is somewhere on the right side of the mean here. And less than means this. That means these are the people, men. These are the men that go through the door without bending. So how do we do this in your stack crunch? You will first, you change your mean to 69 with a standard deviation of 2.8. And you're looking for less than 72. So because and this is the answer here. So we type this out. So Px less than or equals to 72. Your answer will be 0.8580. Any question here so far for me? Oh. However, if you give me this or you give this in the answer in your homework, they mark you wrong. So can someone tell me why this is wrong in your test, in your homework? When everything looks right? Stack crunch looks right. Your picture match. All the numbers you put in is correct. So, know why this is wrong.
Percentage.
Yes, very good. So last time the question asked you for probability. You can leave your answer in decimal, but this time the question asks you for percentage. Then make sure you convert this into percent. So it should be 85.8%. So when you guys do your homework, read the question really carefully if they want percentage. So you make sure you watch out, you change it to percent. Okay. If your question wants to probability, then leave your answer in decimals. Okay. Very good. So watch out for those things. I'm not very picky. I mean, in the test, you won't get 0. I mean, I would just probably take half a point off. I mean, it's a very minor mistake, but in your homework, they will mark you wrong for sure. Question B, this time we will do for the women's. So the percentage of adult women that go through without bending, again, that means less than 72 inches. So the mean for the women's height is normally distributed with the mean of 63.6 and the standard deviation of 2.5. Okay. Now we want to figure out 72 inches. 72 inches is somewhere here. 72 inches. Again, without bending means it has to be less than 72 inches. So this is we're gonna use that for the picture for question B here. So now we have to, in StatCrunch, you have to change this to 63.6 with 2.5 inches. And you're still looking for less than or equal to 72. So this is 0.9996. So that is the percent. That is not the percent, that's the probability. So the probability of x less than or equal to 72 in this case is equals to 0.9996. And again, this is wrong. You have to change it to percent. And the percent in this case is 99.96%. Now, some students will ask me about, can I write this as 100%? Or round it to 100%? The answer is no, because 100% means every female or every woman can go through this door without bending. But we are not 100%. We still have the 0.04% of the women that is taller than this door, means they have to bend. We have to go through this door. They have to bend over to walk through this door. Okay. So make sure you guys know that do not round any answers until, although some people want to round, especially to 100%. It's a very different story in this case. Anyone have any questions? In question C, the doorway height would allow 98% of the men without bending. So what happened is that if you have a 72 inches height, you find out that 85.8% of the men can go through this door without bending. That means around 14.2% of the men has to go through this door, have to bend over to go through this door because they're taller than that. So now the question says, I do not want 85.8. I want what? 98%. So how tall the door height should be if you want more men to go over this without bending? So you know that the answer should be taller, higher than 72, because that will be a lot more guys to go over. So in order for you to do this question, this is again the special one, which is what we just did here, is this 98% is your probability. Okay, so let's draw the picture for this one for question C. Okay, so for this case, we are still doing men, not women. So man has is normally distributed with a mean height of 69 inches and the center of 2.8. So this is again man's. About man here, and then allowed 98%. So 98% is a lot. So last time 86% is around here. So 98% is somewhere here. So that means that this is 0.98. And you want to figure out what is the value of the door height in this case, where this will be your probability here. Okay, so for this question, you have to switch around a little bit. So again, we're using man 69 and a standard deviation of 2.8. Okay. Now we need to put the 0.98 on the second box. Okay, 98%. On the second box, that's your probability. So this is the door height you need to do. So 72 inches, now you have to go to 74.75. So the answer in this case will be 74.75. And this one has units, don't forget. So this is inches in this case. Oh, this one also has unit, forget to mention. This is your IQ score. So this will be your unit here will be score in this case. So make sure you guys know that when you find the value or find the z-score, it has a unit on it. So this is your answer. And how do we write this as your the last row? You just put P x less than or equal to the box. And this is equal to 0.98. And the box you have is the answer given to us. So what this means is if you change the height of the door from 72 to 74.75, 98% of the men will allowed to go through this door without bending over. Okay, so we still have that 2% of men to do it. I have to bend over, but the rest is fine. Okay, so this is how we do these questions here. Anyone have any questions? Right, we're gonna start with question 3. So again, this and 6.1 and 6.4 are very similar. So that's the reason why that I will strongly suggest you to, if you doesn't know how to do this, watch 6.1 or 6.4. Okay, they are all kind of the same. Engineers must consider the circumference of adult heads when designing motorcycle helmets. So the adult head circumference are normally distributed, very important keyword, with a mean of 570 millimeters and a standard deviation of 18.3 millimeters. Due to financial constraint, the helmets will be designed to fit all adults except those who have head circumference that are in the smallest 5% or the largest 3%. Find the minimum and the maximum head circumference that the helmets will fit. So this question is asking us about designing this motorcycle helmet. Okay, and this motorcycle helmet can only fit for everyone, but only if your head is having the smallest 5 or your head is bigger than 3% of the population. So you have to find the max and mean. So how do we do question number 3 here? Again, the normal curve is drawn here because of the word normally distributed. The mean in this case is 570 with a standard deviation of 18.3. Now, the question wants us to figure out what is the smallest 5%. So the smallest 5% means that it is the low end. And this 5% is the probability, okay? But again, you have to change this into decimals, sorry. So this will be your probability in this case. So this is the meaning of the word smallest 5%. Oops, sorry. And you have to find what is the largest 3%. So in order for you to find the largest 3%, you are looking for this 3% on the high end. So you're looking for the L, which is called the largest, and you were looking for the S for the smallest. Okay. So again, smallest will be your minimum, largest is your maximum. So that means that these are all your probability here. So make sure you guys put this in your second box here. Okay. So let's find the smallest one first. Okay, the blue one first. So we use TechCrunch. The mean is 570 with a standard deviation of 18.3. Okay. So because you're looking for the smallest one, it is on the left side. So it's put the 5% on the second box and you will hit compute. So the smallest 5% in this case will be 530 9.9 millimeters. And how do you put this? You just put it down as the box in the first one. And then 0.05. So this is how you find the smallest five, the minimum. We call this your minimum. Okay, so this is your minimum here. Okay, for the maximum, it's orange. So this case now you have to, the mean essentially is the same. So, but you have to do greater than, because it is on the largest 3%, 0.03. Okay, and when you hit compute, this now is on the other side. So this will be the answer for the maximum. Okay, so the maximum is given us by 604.4 for 2 millimeters. Okay. So if your head size is this size or bigger, then your this helmet would not fit you. Or if you are smaller than that, it's not going to fit you. But if your head size is between those two numbers, then yeah, that will hit you. Can fit through it. So how do we do this? Is make sure you change the symbol to greater than or equal to, because we're doing the highest one. And then the 0.03, highest 3% here. So this is your answer for question number 3. Okay. Anyone have any questions for me with this one? 6.2. I would recommend highly start doing your homework. 6 online homework due on this coming Wednesday. So please work on it. This is something also will come up in your test. And I know it's due on Wednesday, the midnight. And guess what? Your midterm is on Wednesday at 10 in the morning. So make sure you guys don't procrastinate and wait till the midnight on that day to finish it. And you probably do really badly in your test, because these kind of questions will be on your test in this case. Okay. So before we continue with the last section, 6.4, I'm taking attendance here. So make sure you guys give me that attendance here. And yes, we will not do 6.3. We will skip 6.3. Same thing with your homework here. You do not need to do homework 6.3. Same thing with the test. So your test will have 6.2 and 6.4 and also 6.1. So we don't have any questions on 6.3. Okay. Anyone have any questions before we start with 6.4? We are going like a train a little bit now. And then next week you got no class, mostly review and your midterms. So you got some time to breathe a little bit. All right. So now we do 6.4. So 6.4 is called the central limit theorem. The shortcut we call this is CLT. Okay. So when you see CLT, you can use CLT in the test like this. It means central limit theorem. So what is this central limit theorem is? Okay. The central limit theorem is based on the sampling distribution of the sample mean. Oh my God, that is a lot of sample here. And if you read this question, the sampling distribution of sample mean is a distribution of all the possible of sample mean, where all samples have the same sample size and taken from the same population. Oofta, how many samples we have in this sentence? Too many samples. So what we talking about here? Okay, so I will tell you what is the central limit theorem is about. Okay, so we have a population. Population is big, right? We have a big population. And we can, again, in the world of statistics, we cannot study the population because it's too big, a lot of money to be spent, and a lot of time to be spent. Like coming election, we don't have time to study the entire US population who's going to vote for this coming November election. So what do I do is I pick a sample out, random. Okay, I put S for samples. And let's say I take 50 samples, usually up to you, but the word random has to be there. Okay, so make sure. So let's say I'm talking about the height of the population in America. So I pick 50 samples of the population. I measure these 50 people, US people, US citizen or US residents, and I find the mean. Now this mean is X bar. Okay. So let's say the height of these 50 random select people, let's say is 68 inches to make it easier. Okay. So in a dot plots, I will put, let's say this is 60, 70, and then 80 example, and maybe 50s. This is an example. So this 68 is somewhere here. I put a dot over here. Okay. Now, so what is, this is called a sample size N. So N is 50 in this case. Okay. And we are doing the sample mean. This is the sample mean 68. Okay. Taking from the same population. And guess what? I have to take another 50 US population to form another sample randomly again. Now, the sample mean in this case, you know, it's not going to be 68. It might be a different number. Let's say this time is 65. I'm going to dot right here, 65 is somewhere here, right? Okay. So this is, so what happened is I keep on drawing every 50 samples. Maybe I do it, you know, all the samples here. Or this is how we do in the world of statistics, okay? So we keep on taking samples, and you know that every sample will give us a little bit different mean, right? Sample mean. Okay, so let's say this one is 70, and let's say this one is 68. So 68, we're gonna power it out. Okay, so I am going to do this because we do it 50. So we're gonna do it 50 times. So we're gonna do this sampling 50 times. Okay, so now I got 50 dots, right? I got all these 50 dots. So can someone tell me what happens if I put all these 50 samples, the sample mean of this, all these 50 dots in this case, what is it looks like? This is a world of statistics. Anyone want to figure out what the shape of this, if I keep on dotting all this, 50 times, right? I collect this sample 50. What it would be that? Anyone wants to take a guess? No one say anything. So this is called the central limit theorem. Okay. If you pick your sample size more than 30, anything above 30, like we do 50 here, it will become a normal distribution. Okay. So in other words, if I put the dots of all these 50, this fellow will become a normal distribution. This is called CLT. Okay. This theorem is the most important theorem in statistics. Like if you think about algebra, then you think about Pythagorean theorem, right? That you guys all know. So that is an important theorem in algebra, right? That's the first theorem you learn, and it's important. Same thing happens in the world of statistics. This CLT is our first important theorem that we have. Without this theorem, statistic class ends right here. We don't have any more, okay? But with this theorem, it's really keep on, develop more stuff, okay? So what else do the central limit theorem says besides it is a normal distribution? It says that the sample mean is gonna be it also say that the mean for this normal distribution is mu, and the standard error in this case is sigma over square root of n. So this the mean here, oops, sorry, lines, is gonna be mu. But your standard error is gonna be sigma over by square root of n. And what is sigma? Sigma is the population standard deviation. And n in this case is your sample size. How many you pick? 50 in this case. Okay. So this is central limit theorem. This whole picture is called sampling distribution of the sample mean. Long words. I'm gonna type this quicker that way. So this called sampling distribution. This is a shortcut here of the sample mean. Okay, the whole picture is called sampling distribution of the sample mean. It means that in this case, this value that you see here, last time remember it's called a z-score or the x value, but this time this value is called your x bar, which is your sample. Okay, so this is your sample mean on the x. So this CLT is very, very important. If you pick, when you use this CLT, you will use this CLT when you pick as n. That means that you pick people out. Okay. So if you look at the question 6.2, usually we only pick one person. So all this is doing one person. We are picking one people. Okay. We're not doing a group of people here. So everything we do here is one person here. Sometimes you can tell by looking at the keyword here, random sample. So you find out that this is for one person. Okay. So that's why we don't use CLT in this case. You only use CLT when you pick a group of people. Okay. Example. A good example to use the CLT is that you go inside an elevator. When one person go in the elevator, you do not worry about the elevator got stuck, right? Because it's one person. No way that the elevator gonna be stuck. But what happens if n people goes in, a group of people of us go in? Now you worry the elevator might get stuck because it might be overweight. So that is where the CLT is used for. So again, make sure you guys know CLT is used for when you have n people in this case. Okay. Now there are some requirements or conditions in this case. Okay. So these are the requirements and conditions. So make sure you guys know the requirements and condition. Okay. So the requirement is first, I'm going to highlight this in red, you can see it. The requirement says that your n has to be normally distributed, or your population is normally distributed. And the keyword here is or. I don't know you guys know what is or stands for. That means one or the other. I cannot highlight that follow. So make sure I cannot highlight you. So this is the or statement here. So when I say or statement in this case, means that it is one or the other, means of both. Okay. So if you have your population is normally, or your sample size is more than 30, then your distribution is going to be normally distributed with a mean of mu and the standard error of sigma over square root of n. Okay, so this is the good things about CLT. Okay, what happens if your population is not normally distributed and your sample size is smaller than 30 or smaller? Now the keyword here is n. N means that both of this. Okay, so if you have such case, then it cannot be normally distributed. That means that you are not allowed to use CLT in this case. Okay, so make sure you guys know this. This is very important. So if you guys want to be a stats major or going for your stats, your classes or stuff. So CLT cannot be used if your population is not normally distributed and it's a big keyword here. Sample size is less than equal to, and means that both of these. Okay. So if you have these two requirements here, that is no good. So we call this method non-parametric statistics. So those who are going for the stats major here, this is called a non-parametric stats. Yes. So when you hit the word non-parametric, so this is where they will doing um they're doing the the CLT not involved in this case. Okay. So you find out there's a weird name in this case. So this mu x bar is called the mean of the value of sample mean, and sigma x bar is the population standard deviation of all the value of sample mean. So again, you don't worry about the symbol here. What you need to know is the requirements, and the mean is mu, population mean, and the standard error, we have a name called standard error, sigma over square root of n. Okay. StatCrunch. In StatCrunch, what we do in StatCrunch is the same as what we did. We use the stats calculator normal. Again, remember the first box and the second box. So the first box is your x score, or in this case should be x value. And then the second box is probability. But the only difference here, class, is your mean is mu. My standard deviation is sigma over square root of n. So when you use CLT in this case, this standard deviation will be sigma over by square root of n. But wait a minute, David, I don't have a square root in my keyboard. So how do I do this in your StatCrunch in the keyboard? So you type in the sigma, let's say 3.4. Don't forget the slash, because that means it's divided. SQRT 50. Okay, again, the 3.4 is sigma and 50 is your n. So again, it can be different numbers here. So make sure you guys type this out in your standard deviation if you have using CLT. Okay. So example, I will show it to you. So let's say that your standard deviation is 18.3 slash SQRT means square root. And let's say you pick 50 people randomly. So this is how you type this into your StatCrunch here. Make sure you put a slash. A lot of students forget to put the slash. That will be a wrong. A slash means divided. So that's why it has to be divided here. So make sure you guys put that in there. And this is where you put your CLT. And I think you guys know about the same rules apply, right? The first box is for the value, and then the second box is for the probability. So when you do the CLT in this case, the first box will be, this will be your probability. And this will be your value. So make sure you guys know which one is which. Anyone have any questions here for me? All right, so again, your test goes up to here. So that's why this is very important here for us. Question number 1 is asking us that you have a population mean height. Okay, there's a big keyword here. Of females is 6, the mean of this female is 63 inches. And the population standard deviation is given us by 7.3 inches. 36 adult females are randomly selected. What is the mean of the sample mean, and what is the standard deviation of the sample mean? So this is asking us to figure out what is the mu x bar and what is the sigma x bar. So the mean of the sample mean is the mu x bar, and the standard error of a sample mean is the sigma x bar. Now, because we're picking 36 adults, so this will be a CLT. Okay. Because CLT says that if you have more than 30, the sample size is more than 30, CLT is required. You are allowed to use CLT. And if CLT is used, then your mu x bar, which is the mean of the sample mean here, is exactly the same as the population mean. So the mu x bar is the same as the population mean mu. We know the population mean in this case is 63 inches. So this will be 63. inches. Okay. And then for the standard error of the sample mean, which is sigma x bar, if it's a CLT, sigma x bar, the standard error is going to be sigma over by square root of n. Okay. So this will become sigma over by square root of n. So sigma is your population standard deviation, which is 7.3 over by square root of n. In this case, we have 36. Now we know root of 36 is 6. Okay, square of 36 is 6. So this is actually 7.3 divided by 6. So 7.3 divided by 6. So that is 1.22. Okay. So this is the answer they're looking for, inches. So the population, the mean of the sample mean is 63 inches, and the standard error of the sample mean is 1.22. Okay. And if I want to draw a picture for this will be a normal distribution because CLT stays that. Okay. Where the mean in this case is 63 inches, but the standard error in this case is 1.22. So we're not using 7.3. We use 1.22. And all this value on the x-axis here is your x bar. That means out of this 36, what is the sample mean we looking for? Okay. And the same thing, every shading area you have, this is your probability. Okay. So this question doesn't ask us for probability or anything. This question is only asks us for what is the sample mean of the sample mean and the standard error of the sample. That's what the question asks. Anyone have any questions here? So later on, you will learn all this about how to figure this out. This is very important section here. Let's read question 2 here. It says that SAT scores are normally distributed with a mean of 1518 and a standard deviation of 325. Now, because this question did not mention anything about sample size or how many people we pick, this is talking about population. Okay, so this whole sentence on the first one is population. Okay. And now when you talk about one SAT scores are randomly selected, find the probability. This is between 1550 and 1575. Now, this is where you pick one person. This is where we talk about the sample. But when you do this, because you're picking one people, for question number A, CLT does not apply. The reason why CLT does not apply is because CLT can only apply if you pick N people. Okay, that means N subjects. But if you're only picking one, we do not use CLT. That means we still use back 6.2, the one that you just did before that. That means in question A, in order for us to do this question, the mean in this case is still the same, 1518. The standard deviation is still the same, 325. And the reason why we don't use CLT, because if you take this over square of 1, because your n is 1, you know that square of 1 is still 1. And anything over by 1 is still the same thing. So that's the reason why that is kind of redundant to do it. So that's why you can use back the same thing. And then they ask you for what is the probability that this is between 1550 and 1575. So around here. Okay. So how do we do question number 1 here? We will use the normal calculator where the mean is 1518 and your standard deviation is 325. Oh, I need to find the between. So I'm click the between one, and you need to find the probability between 1550 and 1575. Okay, so this is how we do this question here. So when you hit compute, This is your answer, and it's very tiny. Yep, it's right here. It's not the same. David, this is not the same as the picture. Because this is nicer than the picture. So this is your answer for question A here. We don't use CLT here, and make sure you put in the very last number here. Okay, 1575. This is equals to 0.0304. Anyone have any questions how we do this? But for question B, is asking for 25 SAT students. Find the probability that the mean is between 1550 and 1575. So what is going on in question B is now we're not talking one, we're talking about 25 people. And you figure out what's the probability of the mean. When I say the mean means we got 25, means the mean of this 25. I add all these 25 SAT scores and divide it by 25, the mean is between that. So in this question, if you are doing question B, this fellow is CLT. The reason why we use CLT in this case, because we got a group of people. Okay. So when you use CLT, the mean in this case is 1518. Still the same, which is written down here. Your mean is still the same as the population mean. However, your standard deviation will be 325 over by square root of 25. Or we call it a standard error. Okay. So this is only happens when CLT happens. And since we know square root of 25 is 5, okay, so you can do this in your, and then we still need to find in between the 1550 and 1575, the same two numbers here. So how do we do this is as in StatCrunch is exactly the same as what we did, but the only difference here is your standard deviation or standard error in this case is going to be over by 5. Okay, or if you want, over by square root of 25. So if you doesn't know square root of 25 is 5, you can put it this way, or 5 if you know square root of 5. That will become 0.1210. So this will change it, so you can tell it's a little bit different from him. So this question, the answer in this case will be 0.1210. Okay. So this will be 0.1210. So that is what's the how we figure out the difference between the CLT and no CLT. One is using 1 people and the other one using n people. But then it's continue mention about why can this use CLT? Why we can still use normal distributed? Even though the sample size does not exceed 30. Remember that CLT mentioned that CLT mentioned about in order for you to use CLT, your n has to be more than 30, right? But in this case, in question B, your n is just 25. Okay, so why we can still use CLT? Do not forget that central limit theorem, the requirements stated that either you have sample size or your population is normally distributed. So for question 2, we know that the sample size is not more than 30, but we find out that the original population is normally distributed. Where is it at? It is stated right over here. Remember when you use this, when you use this word, the SAT score are normally distributed. It telling us that your original population is normally distributed. So that's why in order for us to see that, CLT states that the original population is normally distributed. CLT can be applied. Can I see that or no? There you go. Okay. So make sure you guys know that when you use this, we can still use CLT here as long as your population is normally distributed or your sample size is more than 30. So you can tell that by every single questions we have done, they all have the word normally distributed in it. It's just telling us that the population is normally distributed to cover up CLT in this case, because that means you do not need to worry about how big your sample size N can be used. Okay. So not CLA, CLT here can be applied. So that's why we can still use CLT in question B because of the word normally distributed. You guys doing all right here with question 2? A little bit tough. Yeah, this is kind of a little bit tough here. So let's read question 3 here. So Southwest Airline currently have a seat width of 17 inches. Men have a heat breath that are normally distributed with a mean of 14.4 and a standard deviation of 1.0. Again, when you read this whole questions before we read A, B, and C, you notice that this is a population sentence. That means that the normally distributed is our population. This mean and standard deviation is also from the population. And then what we do in this case is in question A, they ask us to find what is the probability that an individual man has a heat breath that is greater than 17 inches. Again, when you do the probability in this case, we do not need to use CLT. The reason why we don't use CLT in this case is because we are picking one person. Okay. So in order for us to do question A, we do not, the mean in this case is still 14.4. And your standard deviation is 1. Okay. And you want to find that is greater than, probability that's greater than 17 inches. 17 inches somewhere here. Okay. So how do we find this probability here? We will use a normal calculator. 14.4. That's a wrong number here. And the standard deviation here is 1. And I'm back to standard here. You're going to find greater than 17. So the answer is this. So this is how we do question A, where CLT does not need to apply because we are picking only one person. So PX greater than or equals to 17. This is equals to 0.0047 if I round to 4 decimals. Question B is asking now 122 people here. So if you have 122 random selected men here, okay, what is the probability that the mean heat breath is greater than 17 inches? So now we are talking about 122 for this case. So we will have to use the CLT here. Okay, so for this question here, CLT will be used in this case. What's the difference between no CLT and CLT? The mean is still the same, 14.4, but the standard error is 1 over square root of 122. Okay, so now the only difference here is this 2, the standard deviation, but we still figure out what is the probability that is greater than 17. Okay. So in other words, in this case, it's going to be exactly the same. What we need to do here is we just need to change your standard error to slash square root of 122. Okay. And 122 is not a perfect square. 121 is a perfect square of 11. 11 times 11, but 122 is not. So you just do that. And make sure you put a slash on after the 1. The slash can be found above number 8 in your keypad. Okay, so this answer will be 0. Yes, the chances of that happen is 0. Okay, so PX greater than or equals to 117 in this case is going to be exactly 0. So what does that mean when I say the chances is 0? It means that if I take 122 mans and find what is the mean of it, it won't be more than 17 inches. The chance of you getting that is 0. So that's why a lot of people were complaining about, oh, this seat is too small because I'm tall enough and my leg cannot fit in there, right? Because the seat is too small for me. But if I take 122 man here, and if I find the mean of this 122 man, I found out that there's no such case happen, 0. Okay. So this is usually what the question likes to ask in part C. Okay. And this is what usually you get in the in your homework, not in your test. They will ask in part C, they will ask you about this. Which result do you consider to be what we will use? Is that result in part A, or is that result in part B? Okay. So so in this case, the question is asking us that the question is asking us that which result should we use in this case, part A or part B in this case. Now, then I'll ask you, how many people sit in a plane? One person or a group of 122 people? If you say one person, then we are looking for result in part A. If you're looking for a group of people, that is part B. So how many people can sit in a seat? One or a group of people? So we only can sit one person. So in this case, result in part A is used because only one person can be seated in a seat. That means that the probability that you calculate in part B is useless because there only one person can be seated. So example is in your homework, they will ask you one person and then ask you a group of people, and then they ask you which of this probability you want to pick. Then you need to use your common sense. If you're talking about doors, like going through the door without bending, how many people can go through this door without bending? One person or group of people? One person. How about getting your heartbeat or your temperature? You know, what is your temperature, human temperature? All one person. SAT score, one person. We don't do a group of people. The only time that we do a group of people is where you are in the elevator or you are in a ship and you scared the ship is collapse because it's overweight. If one person in the ship, I don't think so. You are not worried about the ship will be the ship will be collapsed because only one person. But if a whole group of us go in there, then you might need to worry about that because you might be scared about collapsing in this case. Okay, so make sure you use your common sense to figure out which one of these use. If you are using only one person, only can be done sit or stand or walk through it, then you pick one person. But otherwise, if you're talking about a whole group, then we use the whole group in this case. Okay. So so we're gonna still continue a little bit here. Where is this come from? But I will be getting rid of it. So the last question is number 4 here. This is the last question. A ski gondola is carrying skiers. So a ski gondola is where if you go to a ski mountain or ski resort, you carry people in. So is that one person or a group of people is more important? So if it's one person in a ski gondola, I think you are not worrying about it's not working. But if you have a group of us go into the ski gondola and take it up to the mountain, I was scared it will be broke. Okay, because we are the whole group of us. So like this question 4, we are looking for a group of people, not one person. Okay. So usually in this kind of C gondola or the elevator, you always bear a flag stating that the maximum capacity is 12 people or 2,004 pounds. Okay, so that means that you see this in your elevator, right? How many people is in there, or total has to be this much. So this says 12 people or 2,004 pounds, means that as an average, a mean of a person is 2,004 divided by 12. So that means that average one person has to be 167. So you know when you guys came into the elevator, it says this 12% or 2,004, and let's say 12 people came in. What do? You do some math, right? Oh, right. Let's take 2,004 divided by 12. So that means around 167 pounds. It means you assume that every single one of us is either 167 pounds or less. Otherwise, your elevator will stuck, will not be going up, right? So you're worrying about that more than so you're doing this. So this 167 is used throughout the whole time here. The reason why is it comes from this 167 here. Okay, it comes from here. Okay, so I think when you do your homework here, they will ask you this number first. So how do you find this number? Is make sure you take the total amount of weight over by how many people maximum can be in there. Okay. The question continues saying that because men tends weight more than women's, the worst case scenario is where 12 of these are all men. Okay. Assuming that the men are normally distributed with a mean of 102 pounds and a centration of 29 pounds. Again, this last whole sentence that we just did in this case is going to be for the population. Okay, because didn't tell us how many men we pick. So this means everything in this sentence will be a population. Okay. So question A is asking us is what is a probability that an individual man, one man, go to the elevator and the weight is greater than 167 pounds, which is the same weight here. So for this question, we are not using CLT. The reason why is because we are drawing one person here. So for question A, we just do the same thing. The mean for the man in this case, weight 172 pounds with a standard deviation of 29 pounds. 167 is right here. And the question one is greater means the shading is on the right side. So in order for you to do this question, we will have to use StatCrunch. And again, if you do your homework, if you're not using StatCrunch, you use the table. This is a half a page long to do it. Okay, to be honest with you. So mean is 172, centration is 29. You have to go more than 167, or greater than 167 pounds. So that is 0.5684. So I'm going to put this as the rate one. So Px greater than or equal to 167. This is equal to 0.5684. Okay, so this is doing question A. Now for question B, now we're doing the 12 men in this case. So 12 men are randomly selected. What is the mean of them that is greater than 167 pounds? So for this question, CLT will be used. The reason why CLT will be used here is because we're doing 12 men. So the difference between CLT and no CLT is the same. Let's see the same. Similarity is the mean is still the same, but your standard error is no longer 29. It's 29 over by square root of 12. And we still use the same 167, and we still use above. So, so what is the difference between the A and B, 1 and 12, is your standard deviation here. So make sure you put the slash and the SQRT and the 12, and then make sure you close your parentheses. Make sure you have parentheses on the numbers here, opening and closing. The rest is the same, 172 and more than 167. So that chances is a bit more higher, 0.7248. So that is the probability of the 12 people in this case. Okay. So 167. This is equals to 0.7248. Now we look at question C. Question C is asking us that which gondola has the correct weight limit in this case. Okay, so excuse me. So which gondola has the correct weight limit in this case? So in order for you to do this, because as you guys, if I point out early on that the group is more important here. So that's why we will pick the group one. Okay. So in order for us to do question C, which gondola appears to have a correct weight limit? The part B in this case. We will say some type here. We will use part B because the 12 people can be stuck in the gondola compared to one person. Okay. And is this, so we're going to use this 12 people. So my next question is this appear to be correct weight limit? No, this is a wrong weight limit because, oops, sorry, I didn't go up. 0.7248 is higher than 5%. So in order for us to answer yes, this is the correct weight limit, then this probability that you use here has to be 5% or less, okay? However, this is 72%. I would not even want to go into this gondola. That means when you go into the gondola, 12 people, 12 men go into this gondola, 72% of the time it gets stuck. So you do not want to go in there. To be more precise, in order for you to go in there, this percentage is only 5% or less. So that means that this is the wrong gondola in this case, wrong limit. Okay, so if a government came in and look at this, they will call them to change the plan. Cannot be 12 people, maybe 8 people, you know. So so make sure this is very important, especially you are doing the inspection of all this plaque and everything. So now we're going to go to the very last question. I know I burned a little bit more time here. Okay. The last question is asking us that if every man that carries 6 pounds of equipment, okay, and what is the probability that 12 of these men will be having the weight limit that is greater than that? So this part C is a very special case because this is where everyone is carrying, part D is everyone is carrying an extra 12 pounds. Okay, so so what happens? Okay, so extra 6 pounds. Sorry. So as you guys know that the limit, the what we have here is all doing just the man without carrying any equipment. As you know that when you go skiing, you have to wear extra jackets and you have to bring those ski equipment. Those are heavy stuff, right? So let's say everyone is carrying extra 6 pounds. So what is the probability that this means? Now we know that without carrying the 6 pounds, it's really 72%. With carrying the 6 pounds, this percent goes up. Okay. So this is something I will bring it out. What is the mean in this case? The mean in this case will be increased. It used to be 172. Since everyone is carrying 6 pounds equipment, you add 6 to it. So now the mean is 178. But your standard deviation is still remain as 29. Why the mean you add, the standard deviation remains the same? The reason why is because of the definitions of standard deviation. So standard deviation means that it is the deviation from the mean. So if everyone carrying 6 pounds, that means let's say you are 150 pounds, you also carry 6 pounds, become 156. The difference between 156 and 178 is 12. And if you look at the normal one before you carrying is 150 and 172, the difference is also 12. You find out that the deviation is the same no matter you're carrying 6 pounds more or 10 pounds more. So in other words, your standard deviation in this case stays the same. This is very important. Okay. And so in order for you to find this probability, we're going to use CLT because they are doing 12 men in this case. Okay. So your mean in this case is no longer 172, it's going to be 178. Your standard error is still the same, 29 over by square root of 12, because we are doing 12 people. And we want to find greater than 167. So 167 over here, greater than this shape. So if you look at your stack crunch, it's going to be exactly the same. The only difference here is your mean, because your mean, you have to add 6 pounds to 178, but the standard deviation and your probability is still the same. So this time your probability is going to be 0.9056. So this probability is going to be 0.9056. Kind of a common sense to us that, yeah, this one should be higher than chances of that is higher since you carry more weight. This definitely will have an even worse chance of get stuck. Okay, so so this question number 4 is actually coming up in your test. So make sure you guys know how to do this question in the test. And again, this homework is also due on Wednesday the 3rd. So in other words, you got 6 homework due on this coming Wednesday. Quite a bit of homework here. So I would recommend you guys to do this homework. Okay, so this is don't procrastinate. This is also come up in your midterm. This is the end of your midterm here. So we're gonna stop here. I know I burned down a little bit time here. So I